So we are going to design a push-down automata for the language L is equal to W power R such that W belongs to A comma B the whole star. W is string formed with A and B. So if your W is can be any strings that can be formed with A and B. If your W is equal to A, B, B, W power R is reverse of W, that is B, B, A. So for designing this push-down automata, what logic we can use is we can push the symbols that are in W, and for when W power R comes in, we can pop if B is in the top of in the input tape and B is in top of the stack, we can pop it. If A is in the top input tape and A is in the top of the stack, then we can pop it. So when we have same symbols, we can pop. When we have different symbols, definitely we have to push. There is no doubt about it. But when we have same symbols, say for example, see here B is coming. Again this B is, take this example, W power R to be A, B, 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 A. Now here first symbol A is coming, no problem, push it. B is coming, different symbols, so we can push that also. When X is pointing to B, we can push this A and B inside stack. So A can be pushed, then B can be pushed, no problem. Now, for this pointing, X pointing to B in the input tape, B is in the top of the stack. At this point, we don't know whether we have reached the middle of W. So there is a non-determinism here whether to push or pop in this particular case. So as far as our example is concerned, we need to push it. Only then while popping, we can pop with equal number of B's and A's this side with the A, B, B, A here. But as far as designing the push-down automata here, we have a non-determinism at this point whether to push or pop. So for this particular example, this comes under the category of non-deterministic push-down automata. We can design a non-deterministic push-down automata for L is equal to W power R such that W belongs to A comma B the whole star. Now how to give the algorithm for this one? So first initially our stack will be empty. So if your X is equal to A and your stack is pointing to Z0, or if your string start with B and your stack pointing to Z0, in both the cases you have to push whatever is the tape contents inside the stack, either A or B, and you move tape pointer. This is initial condition. Now after that, if you have input tape as A and stack contents with a different symbol, or input tape pointing to B and stack top of the stack pointing to A, there is no point, different symbols are there. So we don't have any doubt it belongs to only W string. So we'll be pushing that inside the stack and then we will move X. Now the non-determinism lies only when we have both the tape symbols as same. That is, if X is equal to A and Y is equal to A, or if X is equal to B and Y is equal to B. We can also have as if X is equal to Y, like that also we can have. So if X and Y are pointing to the same symbols, then we can either push or pop. So either we can push it in case if we are considering the symbols in W. If the symbols under consideration, or if X belongs to W, then we can push, or we can pop also, pop Y and move X if you are now X pointing to W power R. If your x pointing to w power r, in that case you will be popping. Now once you continue like this, what is the accepting condition? If your x is equal to epsilon and y is equal to z naught, in that case we will accept. So this is the logic we are going to use, and how to give the transition table for this particular problem. So delta transition, looking at the input symbol, state, input tape and stack symbol, how can be the moves. So initially we were in Q0, and what is the possibility? We can have the top of the stack as A, or we can the top of the stack has the possibility of Z0, and input symbol, if it starts with A, it will have A, Z0. If it starts with B, the possibility will be B, Z0. In both the cases, we are going to perform a push operation. Q0, B, Z0. Now after that, if top of the stack is having B and input symbol is A, in that case also, no doubt, we are going to push it. If top of the stack is A and B string is coming, in that case also we will be pushing it. Okay. So this is the possibility of string being in W. Now, if your input tape is having B and top of the stack is having another B, if it is in Q0, if the string this B string that is the string that is coming is in W string, then you have to push it. So you have to give a choice for pushing. If the string that we are considering is coming in, is the first B in W power R, if we think in that manner, in that case we have to pop it. So we will make, for the first pop, we make a transition to Q1, and then that B is popped off. That B is popped off. Now the similar condition you have to give for AA condition also. If both AA belongs to W, then it has to be pushed. Otherwise, we make a first pop and move to some other state called Q1. All other pop operation will perform in Q1. If BB comes, let it be Q1 epsilon, and if Q1 AA comes, it is Q1 epsilon. Okay. Now, what is the condition for acceptance? Now, if you are in state Q1, if epsilon Z0 is coming, then you can go for Q2 Z0. You can accept it. Okay. See, this can be better. This is what is the transition table for this particular problem. Now, how to give the transition diagram from Q0? If A Z0 is coming, you will be pushing. B Z0 is coming, then also you will be pushing. Then what other conditions for push? If you have A and top of the stack B and top of the stack A, in that case you will be pushing. If you have A top of the stack B, in that case also you will be pushing. And if you have A and top of the stack A, if this A coming A belongs to W string, in that case you have to push. And if you have a B and top of the stack B, in that case also you will be pushing. And if it is a B and top of the stack B, there is a possibility for pop also, because if this B we are considering is in W power R. Similarly, for A also there is a pop possible. So this push down automata is non-deterministic because for the same transition A, it can either go for a push operation and remain in the same state or perform a pop operation and move to the next state. So this is non-deterministic. For the same input tape and top of the stack symbol, we have two possible transitions. So it comes under non-deterministic push down automata. All other pop operation it can perform in state Q1. So when A is in the tape and A is coming in the stack, we will pop. B is in the tape, B is coming in the top of the stack, then we will pop. So once you have epsilon Z0, so we can go to the final state. This is Q2. Now we will give the instantaneous description for W is equal to ABB. So the string we are going to consider W power R is ABB BBA. So we are in state Q0. ABBBBA. We are placing it in the input tape and Z0 refers to the bottom of the stack. So the next state is we will be pushing BB. So it is very deterministic and it will be pushing that inside the stack. Again, top of the stack A and B is coming. So it will perform a push operation Q0 B A and BA Z0. Now Q0 BB is coming. See here. Q0 BB is coming. So here we have two possible transition. One is Q0 BB Q1 comma epsilon. If you are going to take this as the transition, then it will not lead to the final state. So after that it has to come back here and trace this path so that it can go to the final state. So if we take only this transition, this move, this will lead, this particular string that belongs to this language will take a path to the final state. So we will take this move. So the next move is Q0 comma BBA comma BBA Z0. We are pushing inside the stack. Now next is we will make a state transition to Q1 and we'll make the first B being popped out. Next we will make for the next B, we will remain in state Q1 and we will pop off that A. And again we will remain in Q1, then epsilon Z0. Next step is Q2 epsilon Z0 accepted. So this works like this. Now here is the crucial part, this move. Here it is very non-deterministic. Only if you take this transition, this particular string which belongs to this language has a path from the initial state to the final state. If we are going to take the next move, it will not lead to the final state. So we have to select this move and make it go to the final state. So this is the answer for language W power R such that W belongs to A comma B the whole star. So for a single transition there are two possible moves. That is why this particular pushdown automata is called as non-deterministic pushdown automata. Thank you.